Hi there, my name is Mr. Von Ah, and we are doing some algebra. In fact, right now we are really focusing on how to graph linear equations. All right, I'm so glad you can join me. In the link below, go ahead and click it. I have some notes that you can print out for your enjoyment. All right. So hey, our objective, we're going to learn how to graph linear equations today. I'm going to teach you, there's different methods. I'm going to teach you just one method. And later on in a different video, we're going to learn how to write equations. Okay? So here I already give you an equation. All right? The equation is x plus 2y equals 2. And the question, they're asking you to graph this. Okay, well, how do I graph this? Well, the first thing you need to understand is you need to get this in slope-intercept form. Okay, what's that? Well, slope-intercept form is y equals mx plus b. This is slope-intercept form. Okay? Why is it called that? Well, quite simply because m, not x, just m. Now m just represents a number. Could be 2, 3, could be negative 1/2. It's a coefficient. Okay, it's a coefficient. M is your slope, and b is your y-intercept. All right, so it's important that I get it in that form in order for me to graph it. Okay, and let me ask you a question. Is this in slope-intercept form? Well, it's not, is it? Because slope-intercept form has y all by itself on the left. Y is not all by itself, is it? It's got this x over here, and I have a 2 here. Okay, I need to move this 2 and that x over to the right side. Well, how do I do that? Well, I use some of my equation solving skills. So I'm going to go ahead and rewrite this equation down here. All right? So I got x plus 2y equals 2, right? I'm just rewriting it. Now I want to get this equation into slope-intercept form. Okay? The way I do it is, first I use my addition principle. Am I adding or subtracting anything? Well, I am. I'm adding this, I'm adding here, right? So I need to get rid of this x. Okay, and I get rid of addition before I get rid of multiplication, right? These two are multiplied together. Right? Get rid of your addition and subtraction first. Okay? So in order to get rid of an x, well, it's really easy. I just subtract x, and he's gone. As long as I do it to the other side, remember the golden rule of algebra, do on to one side as you do one to the other. Okay, x minus x is going to cancel. Okay, and that leaves me with just 2y equals. All right, now these are not like terms. I cannot combine them. And so the question is, okay, what should I put first? Should I put 2 minus x, or should I put negative x plus 2? Well, technically both of them are correct. However, I'm trying to get this in slope-intercept form. Okay? What comes first? The constant, b is just going to be a constant, or my x value? Well, the x value is going to come first. So I want to go ahead and put the x out front. And that's a negative x. And that's a positive 2, so plus 2. All right, so I'm one step closer. However, it's still not in slope-intercept form because I have this 2. Okay, this is 2 times y. Well, what's the inverse of multiplication? It's division. So in order to get rid of that 2, I simply divide by 2. Now watch this. I have to divide everything over here by 2. So I could just go like that, or I'll show you a way that's a little, maybe more visually pleasing or makes more sense. I need to divide this side by 2. That means I can multiply everything on the right by 2. That means this gets divided by 2, and this gets divided by 2. All right, that's going to help. I think you can see that's going to be more helpful, I think. All right, so let's take a look at this left side. I have 2 divided by 2, which is 1. A lot of people say this cancels. It doesn't actually cancel. It reduces to 1. In algebra, we're trying to get everything down to zeros and ones. All right, so this is just 1y, or just y. Okay, now what do I have here? I have negative x over 2. Well, remember, what's the coefficient in front of that x? Whenever there's no coefficient in front of something, a variable, you can always say that there's a 1. Because 1 times anything is just the identity of the other number. It's called the identity property of 1. 1 times 5 is 5. 1 times 6 is 6. 1 times x is x. So there's actually a 1 there. Okay? So what do I end up with here? I have negative 1 over 2x. In case you're wondering, it doesn't matter where I put the negative. I could put the negative on the top, or I could put it on the bottom. Okay? Either one is fine, but don't put it on the top and the bottom. If you do that, you get a negative divided by a negative is a positive. You end up with a positive 1/2, which is not what we have. I prefer to put the negative sign on the top, in the numerator. Okay, so I get negative 1/2 x plus 2 divided by 2, which is 1. All right, now is it in slope-intercept form? It is. You see that? Y equals mx plus b. Now, oftentimes, they're going to give it to you already in slope-intercept form. So you're not going to have to go through some of this mathematical gymnastics, if you will. Okay? So I have it in slope-intercept form. Now I'm ready to graph it. Okay, now the first thing I want to do to graph it is I want to graph the y-intercept. I have to graph the y-intercept. Okay, what's the y-intercept? Well, the y-intercept is simply that constant sticking out at the end. What's the constant I have at the end here? What's the 1, right? That's my y-intercept. I'm going to label that. That's my y-intercept. That just means, hey, where does my graph cross the y-axis? Well, if you look here at my coordinate grid system, I have my x-axis and I have my y-axis. X is the horizontal axis, y is the vertical axis. Okay, so where is my graph going to cross the y-axis at y equals 1? Y equals 1, it's not there, right? That's x equals 1. Y equals 1 is right there. Okay, there's my y-intercept. My y-intercept is at 0, 1. Boom, right there. Okay? So there's 2 things I need. I need the y-intercept and I need the slope. Okay, so what's my slope? My slope is negative 1/2. That's my slope. By the way, my slope is not negative 1/2 x. Remember, slope is just a number. It's the coefficient in front of the x. Okay? So I shouldn't have put that so close there. It makes it look like it's just the 1. All right? That's my slope. Okay, so remember what slope is? Slope is just rise over the run. What do we mean by that? Well, rise, when you think about rise, you know, it's like up or down. Okay, when you think about run, well, there's only one direction you can run, and that's frontwards, or I guess you can run backwards. Don't run backwards. I broke a collarbone one time doing that. All right, so rise is up and down, run is side to side. Right, rise has to do with my y, my change in y. That triangle just means change in. And the run just means the change in x. Okay? For now, we'll just think of rise over run. Okay, so my slope is negative 1/2. My slope is negative 1/2 here. Let me just be consistent with the same color here, right? My slope is negative 1/2. So what I do is I start at my y-intercept, and I gotta say, okay, what is my rise? My rise is negative 1. So what do? I go down 1. I do not put a mark there. Okay, I just rest my pencil there because I still have a run to do. Okay? So now my run is positive 2. So positive direction is this direction. Okay? So positive 2 would be 1, 2. So there's my second point. I need at least 2 points, but it's best to have at least 3. Okay? So I'll just do it again. Starting from this point, rise of negative 1, run of positive 2. 1, 2. Again, rise of negative 1, run of positive 2. 1, 2. Now remember I said that the slope can be either negative 1 over 2 or the slope can be 1 over negative 2. I'm going to prove to you that those are equivalent. Okay, so now my rise is positive 1 and my run is negative 2, right? So let's start at my y-intercept. My rise is 1, up 1. My run is negative 2, 1, 2. And there we go. By the way, my grid lines are not perfect. I just did them by hand, so this is not going to be a perfect straight line. Okay, again, my rise is 1, my run is negative 2. Right? So see how it still just lines up with that? Just goes in the quadrant 2 section. So now the only thing that's left for me to do is draw a straight line. And by the way, you don't have to do this many marks. You need at least 2 marks, but I'm telling you 3 is better. Okay? So now I'm ready to draw my graph. And as you can see, my dots don't line up perfectly, right? It's because my coordinate grid is just been drawn by hand. Okay, so there we go. By the way, you can extend this as far as you want. My ruler's only that long though, so. And I put arrows at the end. Why do I put arrows at the end? Well, because the arrow means that, hey, this line goes on forever in this direction and in that direction. If you don't put those arrows there, what it actually means is the line stops right there. But that's not true. It continues, so that's why we put arrows. Make sure when you're graphing, please, please, please use a straight edge of some kind. It doesn't have to be a ruler, it could be the side of your phone, right? But think about it this way. If we're doing a real life situation, and this represents the income of your company, or I think I should say, this represents the sales of your company. You're going to need accurate information, right? If you got a line that's all over the place, that graph's going to be worthless. It's going to be useless. But if the graph is straight, hey, now I can use this to derive other solutions. All right? So, for example, by the way, what's another solution? What are the solutions to this graph, to this equation? Every point along this graph is a solution to this equation. I'll prove it. Let's take a look at, let's take a look at this right there. That should be on the line. Okay, what's the ordered pair there? The ordered pair is 0, 1. 0, 1. Okay, well, let's see if that works. That means that my x is 0 and my y is 1. So let's go ahead and put in a 0 for x, and a 1 for y. Okay, so I got 0 plus 2 times 1 equals 2. That's a true statement, right? 2 times 1 is 2. and 2 equals 2. True statement. How about this one right here? That is what? 1, 2, 3, 4, down 1, so that's 4, negative 1. That's also a solution to this equation. I'll prove it. Okay, 4, negative 1. Okay, so x is 4. X is 4 this time. And y is negative 1. Okay, so 2 times negative 1 is negative 2, right? 2 times negative 1 is negative 2. And then I got a 4 over here. So 4 plus a negative 2, or just 4 minus 2, equals 2. You see that? So you can get all sorts of different solutions from this graph. That's the beauty of a graph. It's visual, and you can pick off all sorts of solutions. Okay? Every point along that graph is a solution to this linear equation. Okay? So that's getting our feet wet on graphing equations. Make sure you practice. That's where you're going to really learn this. Okay, I hope this video was helpful to you. And make sure you subscribe to my channel. That way you get all the videos that I make. And don't forget to click on the link below in the description box. All right? Till next time, my friends, may God richly bless you.